This is PCP rotor. Actually, whatever I was talking about PCP experiment. So, in experiment we use one PCP. So, PCP is having this one rotor, okay, and I have one stator. Okay. So, you can see stator is having one hole and it is not circular hole, it is having wall type shape. So, this end will go there, okay. And when it is rotating continuously, this rotor, it will be moving one end to another end, moving and rotating, this one end moving and rotating, okay. And this is two stage PCP. Two stage means two pitch is there. How can I say two pitch? I cannot see from outside, but here I can calculate how. This, if you see this helix and this helix, okay, one pitch, two pitch, three pitch, four pitch, okay, four pitches are there, 1, 2, 3, 4, okay, four pitches are there, and four pitches, that means your stator will have 4 divided by 2 means 2 pitches, okay, that means this is two stage PCP, okay. Now you have two stage PCP, and when you are connecting to motor, I said like this is rotating continuously, okay, rotating, and one end one end is moving forward backward, rotating and forward backward, okay. So you need proper coupling. So here I have coupling, actually I removed everything, you see this, okay, this is coupling, okay, small shaft or connector, this is a connector. So you put this connector, one pin is there, you can see this hole, okay, one pin is here, okay. So pin, and here is one hole, you can see there is one hole, okay, okay. So you put here, put one pin, I'll put my pin here, I have pin means I have one pencil. Where is my pencil? Pencil is here. So assume this is my pin. Where is my pin? Yeah, okay. So now it is fixed. Now if it is rotating continuously and moving forward backward, I have lots of flexibility here. You see this end is flexible, okay, this end is fixed, but this end is flexible, okay. When rotating, moving, it will have forward backward motion and rotation, both, there will be no issue, okay. So PCB fails because of elastomeric failure. Why elastomeric failure will be there? The rotor continuously rubbing the stator, I already told, right, you can remember. This is rotor is moving forward, up and down. If this is my cavity of stator, okay, this is rotor. So when it is moving this direction, rotating this way, so this way it is walking, this way rubbing, okay. So one surface will be rubbing, one surface will be walking. Walking means it is just rolling, another surface is rubbing. So rubbing surface will get eroded quickly, okay, elastomeric erosion will be there. And if I have hydrogen pitting will be there, H2S will be reacting with elastomer, it will be creating hard surface instead of elastomer is softer material. So it will be creating some harder material and it will break, okay. Wear out will be there, erosion, wearing, pitting will be created. So rotor, you can see this, my rotor here, I think color you can see here in camera. Rotor, some erosion is there, okay, some rust is here. Rust is here means that because of rubbing action, the surface, whatever surface coating is there, most probably nickel coating got removed, okay. So because nickel got removed, this become rough surface will create further erosion on your stator. So this rough surface creating stator wear, so that will create further wearing here. So whole system will fail, leakage will be more actually. So rotor, okay, and bearing and other mechanical failure also will be there, okay. And surface driving may stuffing box and other failure may be there. So stuffing box can be wearing out, your rod can fail, okay. So those failure may be common, but normally PCP life will be 4 to 6 months. Why 4 to 6 months? 4 to 6 months because this wear, elastomeric failure and this rotor, normally elastomer will be failing more, but rotor also can fail like this. Okay, rotor can break also, it can get clogged if some sand is going there. So sand can be included in this in between rotor and stator interface, or this clearance zone. So when clearance zone sand is there, sand will be rubbing, okay, it will create rough surface, so that will be creating further deterioration of your system. Okay, next, calculation of pump hoses torques. This is a minimum pump displacement, q a min, okay, equals q a actual divided by omega eta. So the units are barrel per day per rpm. Then this q actual is barrel per day barrel per day. Okay, rpm will not be there. This is rotation, this is volumetric efficiency. Okay, so recommended rpm, if you have less than 500 viscosity cp, then your rpm can be 200 to 300, just approximately rpm. If you have viscosity 500 to 5000, then speed can be 150 to 300. If you have more than 5000 viscosity, then your speed can be 100 to 150, 100 to 250. Okay, so you can see viscosity increasing or speed also increasing. If you have low viscosity, actually you have to run pump at higher speed, so the leakage will be lower. But if you have high viscosity, then slowly you lift the pump, and again if you are increasing at very high rate, flow rate is very high. So high flow rate means you will get high frictional pressure drop. You can remember the formula, del P equals FL V square by 2 GD, right? So if fluid velocity high, so in that case your pressure drop will be also high. So in that case you take less flow rate or flow velocity, so that your pressure drop will be lower, because viscosity already high. So when viscosity very high, your F or friction coefficient, friction coefficient, fluid friction, that will be also very high. So very high fluid friction, again very high fluid velocity, your pressure drop will be also much higher. So just try to avoid that frictional pressure drop higher, reduce fluid velocity, your pressure drop will be lower. Now net lift, P lift equals PD minus PI. So PD is a pump discharge, and inlet pressure, intake pressure. Okay, and these are same unit must be there, like for example P lift you are using PSI, then this must also be PSI. And what is PI? PI will be PCH plus PG plus PL minus P tail. So what is PCH? Casing head pressure. PG gas pressure, PL liquid pressure. I'll explain later what is the liquid pressure, gas pressure. Tail pressure means it is a suction pressure actually. Okay, pressure losses associated with auxiliary component. Let's say you have inlet gas separator or something. So auxiliary auxiliary losses. Now pump discharge pressure, PD. So PD equals PTH tubing head pressure plus PL tubing liquid column pressure and P losses. Okay, so tubing head pressure head pressure, and PL is tubing liquid column pressure, and P losses, your tubing flow losses. Okay. Now using this formula, we'll try to solve one problem. So here the problem is given here, like a vertical well bore, expected production rate 629 barrel per day using a PCP. We are assuming conventional PCP. Oil gravity 12 degree API, oil viscosity 1000, casing size 7 inch, outer diameter. So if outer diameter not written, still we have to assume it is outer diameter. Casing perforation depth. So let's draw the picture first. Okay. So this is perforation depth. Perforation depth is given 3281 feet and fluid level 1968. So this is my tubing. Fluid level is given here. Okay. Fluid level is from the surface 1968 from the surface. Okay. Flow line pressure, tubing head pressure 218. So tubing head pressure is PTH equals 218 psi. The pump was set below the perforation 3312. So below the perforation, that means this one 3312. Okay, pump is here. So actual perforation 3281, but your pump is at 3312. Average gas density is given 0.5, liquid density is given 61.4. The casing is vented. Okay, several assumptions you have to take, otherwise this problem will be more complex. So casing is vented to atmosphere, that means there is no pressure here, this is vented to atmosphere. Okay. Flow losses are negligible. Suction flow loss and frictional pressure drop we are not assuming here. Suction losses are also negligible. P tail also, P tail, right, 0. Okay. Casing head pressure PCH 0. No water, gas, sand. So we are assuming pure oil. Pump speed 350 rpm, it is given, less than 350 rpm. Okay. Pump length 33 feet. Pump should not be loaded above the rated pressure. The pump operated 85%, so eta equals 0.85 is given. Okay. Now we have to calculate minimum pump displacement, net lift, pump intake pressure, pump discharge pressure. So the formula is given QA minimum pump displacement. Formula is that QA min. Okay, so Q actual divided by W or rotational speed into eta volume. Okay, so that is giving 629 is given here. Okay, 629 divided by speed 350, we are assuming 350 into 0.85. So, okay, so this is giving 2.114 barrel per day per rpm. Okay, P lift equals PD minus PI, and PI equals PCH plus PG plus PL plus PI equals PCH PG PL minus P tail. Okay, tail already is 0, so it becomes PCH, casing head pressure also 0, this is also 0, so PG plus PL. So this is PG. What is PG? PG become rho G plus G, rho G star G star H gas. Okay, so what is H gas? H gas is here. Okay, this side. So this becomes rho G means 0.05 into 32 into H gas is 1968. so it giving 282 psi. Okay, PL equals 0.985 into 32 into 3312 equals 730 psi. Okay, so PD equals 218 plus 0.985 into 32 into 3281, it becomes 940. So P lift equals, net lift equals PD minus PI equals 940 minus 731 equals 209 psi.